All right, here in section 3, we're going to be looking more at blood and blood flow uh, through the heart and around the body. Now, I don't know how the heart image, the cartoon heart image of two perfectly aligned loops became the image of the heart, but a heart does not look like that. A heart looks more like this, okay? Where there's not a ton of symmetry, there's not a ton of, it's not pretty, right? But it's functional. And we're going to talk about what it does and what it doesn't do now. One of the major things and unique things of a heart is cardiac muscle. Cardiac muscle is designed to be able to beat fully over and over and over again without any break. So the heart, to understand the heart, you have to understand its chambers. It's got 4 chambers. Okay, they're called atria and ventricles. So you have 2 atria, left and right, and 2 ventricles, left and right. Now you might be thinking, hang on a second, this is my left side. And that's true, this is your left side. But this is not your heart. This is somebody else's heart. You wouldn't be looking at your heart like this. So you have right atrium, right ventricle, left atrium, left ventricle. So atria, ventricle, right? Atria, ventricle. And these chambers are not huge chambers. I don't want you to think of them like caverns. They're kind of small. And what they're designed to do is to be able to push blood through your body throughout the entirety of your body. Now, there are valves here. The tricuspid here, the mitral here, the pulmonary valve here, and the aortic valve here. And what they stop is the blood from going backwards. You don't want blood going backwards. If blood starts to go backwards, what ends up happening is you get something called backflow, and that backflow can become very dangerous. Also, the ventricles left and right are separated by this piece of flesh called a septum, and that septum divides these two and makes them into 2 separate sections, left and right. And when you first looked at this picture, you might have seen all these different labels and thought, wow. But when you think of them as 2 atrium, 2 ventricles, and a valve separating everything, a valve that separates the atrium from the ventricle, a valve that separates this ventricle from this pulmonary artery, which we'll get through later, a valve that separates this atrium and this ventricle, and a valve that separates this ventricle to what happens next, which is the aortic valve, which we'll get to later. It's much simpler, okay? It's just literally the chambers and the valves around them. And muscles squeeze the chambers in a rhythmic fashion to push blood around the body. Now, how do we get the blood to squeeze and move in a rhythmic manner? Well, there are 2 areas of the heart that are in charge of telling the heart when to beat. And this becomes extraordinarily important. If you've ever heard of someone needing a pacemaker, they need a pacemaker to replace the SA node. The SA node is a bundle of cells that says beat, 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 almost like in a crew of rowers. You have someone that helps keep time for the entire crew to row at the same pattern. It's the same idea: row, 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 right? And so the SA node or pacemaker stimulates the atria to contract. The AV node stimulates the ventricles to contract. So one tells the atria, one tells the ventricle. And there's a delay. The SA node says go, and then the AV node a few moments later says go. And then that timing is what gives you the thud, 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 thud kind of rhythm. Okay? But believe it or not, what makes the heart sounds is not the beating of the chambers, it's the closing of the valves, which we will get to as we talk more and more about blood flow. So I'm going to pause here. I'm going to make this the first video. Part B, we're going to pick up from this spot because this is talking now about how blood flows through the heart.